So we look at some questions in relation to exponential and natural log functions. So the question here, obviously, differentiate with respect to x the following. So these are your e to the power of ax's. So the reason it becomes a e to the power of ax is that we differentiate the power to get 2, and then it stays as e to the power of 2x. Differentiate the power to get 5 e to the power of 5x. Differentiate the power to get 4 e to the power of 4x. Differentiate the power, minus 2 e to the power of minus 2x. Differentiate the power, cos x goes to minus sin x, e to the power of cos x. Differentiate the power, we get 5 e, power stays the same, ax, 5x minus 4. Differentiate the power, we get 2x plus 2 times e to the power of x squared plus 2x plus 1. And tan x goes to sec squared x, so sec squared x e to the power of tan x. Okay, let's look at some more. So if you look at the natural log ones, these go to 1 over x, but we have to differentiate by the function itself if it's not just x. So 1 over 3x plus 2 times 3, which is equal to 3 over 3x plus 2. This one's going to go to 2x over x squared minus 8. Differentiate the bracket. This one's going to go to 4 over 4x minus 5 when we differentiate with respect to x. This one's going to go to cos x. If we look at times 1 over sin x, which is equal to cos x over sin x is equal to 1 over tan x. And 1 over tan x is also equal to cotan x. So either one of those will do there. Here we're going to have 4x cubed over x to the power of 4 minus 5. This one we're going to have 2x minus 2 over x squared minus 2x plus 1. I think I have another common factor, 2 by x minus 1 over, this is x minus 1 to be squared. So we're going to get just 2 over x minus 1 for that one. Tan x, this one is going to go to tan x becomes sec x, sec squared x times 1 over tan x, which is going to be sec squared is 1 over cos squared, and tan x is cos over sine. So that's going to give me 1 over cos x times 1 over sine x. The cos will cancel with one of the cos squareds. And cos x sine x is a half sine 2x. We've had that in one of the other videos. So that 2 would jump up on top. So this ends up as 2 over the sine of 2x. That'll be the final answer for this one. This one's going to be minus 4 over 1 minus 4x. This one is going to be minus 3x squared over 3 minus x cubed. This one is going to be 3 over 3x, which is just equal to 1 over x. So you can see as you practice them, it just becomes second nature what to do. In these ones we look at product rules. So follow your same procedure. X goes to 1. Natural log of x goes to 1 over x. So you could write f prime x if you wanted, but I'm just shortening it down so I don't have to keep writing the same thing over and over again. So differentiate with respect to x obviously is the question. So we're going to have the first x by the second differentiated plus the second, which is the natural log of x times 1. First differentiated. So we're going to get 1 plus the natural log of x. Second one, x goes to 1. E to the power of 2x goes to 2e to the power of 2x. So we're going to get the first, which is x, by the second differentiated, which is 2e to the power of 2x, plus the second, which is e to the power of 2x, times 1. So we have 2x e to the power of 2x, plus e to the power of 2x. We could factor out e to the power of 2x, keep it nice and tidy, which would leave e to the power of 2x times 2x plus 1. X cubed goes to 3x squared natural log of x goes to 1 over x. The first x cubed by the second differentiated plus the second, the natural log of x by the first differentiated, which is going to leave x squared with the x cancelling with one part of the cube, plus the natural log of x. I should write the 3x squared first. 3x squared times the natural log of x. There's an x squared in both of these, so I got x squared times 1 plus 3 times the natural log of x. On to the fourth one. X squared goes to 2x. E to the power of x goes to e to the power of x. So I have the first x squared by the second differentiated plus the second, which is e to the power of x, by the first differentiated. So I have e to the power of x factored out times x squared plus 2x. So the quotient rule, again, differentiate each, 2e to the power of 2x and a 1. Quotient rule is the bottom to be squared, the bottom by the top differentiated minus the top by the bottom differentiated. So we're going to get, we have e to the power of 2x as common on top. That would have to be multiplied by my 2x, which is left, minus 1 over x squared. Second one, natural log of x squared goes to 2x. This differentiated on top, and x squared on the bottom, which is equal to 2 over x, and the bottom goes to e to the power of x. So the quotient rule, bottom squared, e to the power of x to be squared on the top, the bottom by the top differentiated minus the top by the bottom differentiated, and tidying this up, we have on top, we have common e to the power of x, which would leave 2 over x minus the natural log of x squared over e to the power of x squared, or e to the power of 2x. We multiply or indices, just be careful. So we're going to get on top, that can be e to the power of x by 2 over x minus twice the natural log of x, bringing the power in front, over e to the power of 2x. And e to the power of 2x is equal to e to the power of x by e to the power of x. So that's going to cancel. Where I'm going to get on top, this cancels with one of the parts on the bottom. So on top I'm left with 2 over x minus twice the natural log of x. And on the bottom I just have e to the power of x. And if I multiply every term by x, I'm going to get 2 minus x by twice ln x. And on the bottom I'm going to have x e to the power of x. I also have a common 2 on top now, so I could take a 2 out and write 1 minus x ln x, and on the bottom x e to the power of x. A little bit of work on that one. I don't think you can get there much quicker. Maybe you can. Okay, differentiating this one and this one. Top one goes to minus 2e to the power of minus 2x, and the bottom one just goes to e to the power of x. So I'll come across here to give myself some room. So the bottom squared, e to the power of x plus 1 to be squared. The bottom, e to the power of x plus 1 by the top differentiated, which is minus 2e to the power of minus 2x, minus, so the bottom by the top is differentiated minus the top, e to the power of minus 2x minus 1 by the bottom differentiated, which is e to the power of x. So multiplying out these brackets, e to the power of x by minus 2e to the power of minus 2x, where we'll add the indices, so it's going to give me minus 2e to just to the power of minus 1x, and I have the 1 by that guy, so that's minus 2e to the power of minus 2x. Then I have this guy by this guy, so it's going to be the minus e to the power of minus x again, and then we're going to have a plus the two minuses, plus 1 by e to the power of x plus e to the power of x, all over e to the power of x plus 1 to be squared. The best way to tidy this one up is to multiply everything by e to the power of 2x, try and get rid of some of these negative indices. So I'll start with this one. That's going to give me e to the power of 3x. Then I'll go to these. This is minus e to the power of x. I have minus 3e to the power of minus x. I'm going to end up with minus 3e instead of minus x. I'm going up 2 to x. And then if I multiply this one by e to the power of 2x, it's going to be minus 2e to the power of 0, or just minus 2. On the bottom, I just have e to the power of 2x by that bracket to be squared, e to the power of x plus 1 to be squared. So this looks a bit tidier than the previous line.